So today we are going to see the introduction of file handling in Java. So far we have used variables and arrays for storing the data inside the programs, and this approach has the following problems. The data is lost either when a variable goes out of the scope or when the program is terminated. And secondly, it is very difficult to handle large volumes of data using the variables and arrays. We can overcome these problems by storing the data on secondary storage devices such as hard disk, floppy disk, and pen drive, etc. The data is stored in these devices using the concept of files. So what is file basically? The data stored in file is often called persistent data, that is permanent. A file is a collection of related records placed in a particular area in the disk. And what is a record? A record is composed of several fields, and a field is a group of characters. Characters in Java are Unicode characters composed of 2 bytes, each byte containing 8 binary digits, that is 0 or 1. Storing and managing data using files is known as file processing, which includes tasks such as creating the files, opening files, updating files, manipulation of file data in the file, and finally closing the file. Java supports many powerful features for managing input and output of data using files. And reading and writing of data in a file can be done at the level of bytes or characters or fields depending on the requirements of a particular application. Java also provides capabilities to read and write class objects directly. A record may be represented as a class object in Java. The process of reading and writing objects is called object serialization. Now we will have the concept of streams. In file processing, input refers to the flow of data into the program, and output means the flow of data out of a program. Input to a program may come from the keyboard, the mouse, or the memory, a disk, or network, or another program. Similarly, the output from a program may go to screen, the printer, the memory, the disk, a network, or another program. Java uses the concept of streams to represent the ordered sequence of data, a common characteristic shared by all the input-output devices. A stream represents a uniform, easy-to-use, object-oriented interface between the program and the input-output devices. A stream in Java is a path along which data flows. It has a source and a destination. The source is the place from where the data originates, and the destination is the place where the required information is going to be stored. This may be either a hard disk or a pen drive. Both the source and destination may be physical devices or programs or other streams in the same program. The concept of sending data from one stream to another has made streams in Java a powerful tool for file processing. We can build a complex file processing sequence using a series of simple stream operations. This feature can be used to filter data along the pipeline of streams so that we obtain data in a desired format. Java streams are classified into 2 basic types, input stream and output stream. So what is an input stream? An input stream extracts or it reads the data from the source file and sends it to the program. An output stream takes the data from the program and sends it or writes it to the destination. The program connects and opens an input and output stream to the destination place of data and writes the data serially. In both the cases, the program does not know the data. Now, what are the stream classes available in Java? The java.io package contains a large number of stream classes that provide the capabilities for processing all types of data. These classes may be categorized as the byte stream classes, that provide support for handling input-output operations on bytes, and character stream classes that provide support for managing input-output operations on characters. These are the two groups may be further be classified based on their purpose. Byte stream classes contain input stream classes, and character stream classes contain reader classes and writer classes. Byte stream classes have been designed to provide the functional features for creating and manipulating the streams and the files for reading and writing bytes. Since the streams are unidirectional, they can transmit bytes only in one direction, and therefore Java provides two kinds of byte stream classes: input stream classes as well as output stream classes. The superclass input stream is an abstract class, and therefore we cannot create instances of this class. Rather, we may use the subclasses that inherit from this class. The input stream class defines the methods for performing the input functions such as reading bytes, closing the streams, marking positions in streams, skipping ahead in a stream, or finding the number of bytes in a stream. These are the input stream methods. The first method is read, which reads a byte from the input stream. Second one is read the number of bytes or an array of bytes into B. Read. The third one is read again. Read m bytes into B starting from nth byte. And fourth one is available, returns the number of bytes available in the input. And fifth one is skip. It skips over n bytes from the input stream. Skipping means going ahead for reading the data from the file. The sixth one is reset, goes back to the beginning of the stream. The last one, seventh one, is closes the input stream. The output stream classes. Output stream classes are derived from the base class output stream. The output stream is an abstract class, and therefore we cannot instantiate it. There are several subclasses of the input stream output stream can be used for performing the output operations. The output stream includes the methods that are designed to perform the following tasks: writing the bytes, closing the streams, and flushing the streams. And the output stream methods are write. It is used to write a byte to the output stream. The second one is again write the number of bytes, writes all the bytes in the array to the B to the output stream. The third one is write. It is used to write m bytes from the array B starting from nth byte. Close, fourth one, it closes the output stream. And fifth one is flush, which is used to flush the output stream. The data output stream, a counterpart of the data input stream, implements the interface data output and therefore implements the following methods contained in data output interface. And these are the methods which are used for this purpose. Character stream classes. It can be used to read and write 16-bit Unicode characters, and like byte streams, there are two kinds of character stream classes: reader stream classes and writer stream classes. Reader stream classes, these are designed to read the characters from the files. The reader class is the base class for all the other classes in this group. These classes are functionally very similar to the input stream classes, except input streams use the bytes as their fundamental unit of information, while reader streams use the characters. The reader class contains the methods that are identical to those available in the input stream class, except reader is designed to handle the characters. Therefore, reader class can perform all the functions implemented by the input stream classes. Similarly, we have the writer stream classes. Like output stream classes, the writer stream classes are designed to perform all output operations on files. Only difference is that while output stream classes are designed to write the bytes, the writer stream classes are designed to write the characters. The writer class is an abstract class which acts as a base class for all the other writer stream classes. The base class provides the support for all the output operations by defining the methods that are identical to those in output stream class. Other useful input-output classes. The java.io package supports many other classes for implementing the certain specialized functions. For example, random access file and stream tokenizer. Random access file, it enables us to read and write bytes, text and Java data types to any location in a file, and this class extends object class and implements data input and data output interfaces. This forces the random access file to implement the methods described in both these interfaces. Stream tokenizer, it is a subclass of object which can be used for breaking up a stream of text from an input text file into meaningful pieces called tokens. The behavior of the stream tokenizer class is similar to that of string tokenizer class of java.util.package that breaks a string into its component tokens. Then, using the file access file class, the java.io package includes a class known as the file class that provides the support for creating the files and directories. The class includes several constructors for instantiating the file objects. This class also contains several methods for supporting the operations mentioned in the next slide, that is this one. So creating a file, opening a file, closing a file, deleting, getting the name of the file, getting the size of the file, checking the existence of a file, renaming the file, checking whether the file is writable or not, checking whether the file is readable or not. Then input-output exceptions. When creating the files and performing the input-output operations on them, the system may generate input-output related exceptions. The next slide is used to give basic input-output related exception classes and their functions. The EOF exception, end of file. It signals that the end of the file is reached. File not found exception. Then interrupted input-output exception warns that an input-output operation has been interrupted. IO exception signals that input-output exception of some sort has occurred. Each input-output statement or group of input-output statements must have an exception handler around it, as it is shown below. Then, creation of files. When we want to create and use a file, we need to decide the following about the file and its intended purpose. Suitable name for the file. Second one is data type to be stored. Third one is support, purpose, reading, writing or updating. Then fourth one is method of creating the file. A file name is a unique string of characters that helps identify a file on the disk. The length of the file name and the characters allowed are dependent on the operating system on which the Java program is being executed. A file contains two parts, primary name and a secondary name. The parts of the file are separated by a dot, test.dat for example. The data type is important to decide the type of the file stream classes to be used for handling the data, whether it is characters, bytes, primitive types, etc. The purpose of using a file must also be decided before using it. Two ways of initializing the file stream objects. First one, directly as a literal string like this. FIS is equal to new file input stream. This is the name of the file. Second one, indirectly by giving the file name, file object that has already been assigned a file name. File, in file is equal to new file of this. So this is the name of the file which is going to be used in this program. So FIS is equal to new input file input stream in file. So this and this should be same. Then we are going to see a program, small program, which is used to copy the characters from one file to another. So first we should have the import statement, import java.io.star, class fh01. This is going to be the name of the file. Okay, so public static void main. Then I am opening this input.dat file in the input mode. Output.dat file is a new file which is going to be storing the output. So I am basically copying the contents from this file to this file. File reader ins is equal to null, and file writer outs, this is in stream and this is out stream, both will be null. Then ins is equal to new file reader in file, and outs, output stream, is going to be from the out file. And int ch, I am going to read the contents one by one, character by character. I am reading, and if it is not -1, if it is not end of file, I am going to write the output to outs. Then catch, I am having the try and catch block here, so it will display it on the screen. Finally, so this will be executed always because it is put under finally. So both the files will be closed. Then it is going to display, okay, contents of input.dat are successfully copied to output.dat, and this is going to be the output of the program. So I am going to execute compile the program, and then I am going to execute the program. So here we get the output, contents of input.dat are successfully copied to output.dat. Thank you.